Hello everyone, my name is Keshav. Today our topic is on operating system virtualization demo. So I'm going to explain what is a virtual machine. It is a software-based computer that runs like a real one. It has its own OS, storage, apps, but works inside computer. Example, running Kali Linux as a guest OS inside Windows 11 as the host OS. And it's used for testing and security without harming the main system. What is a virtual machine? So there are we have used the two OS, the guest OS and another one is the host OS. Host OS is the Windows 11 and the guest OS is the Kali Linux. We have used tool as Oracle VM VirtualBox. This VirtualBox shows how one OS runs inside another safely for testing and practice. And it is a secure. It is VM runs securely inside the real physical machine, the host OS, which is the Windows. For example, like running the Kali Linux within Windows 11. Then it conducts security exercises without risking the main system. Thank you. The next will be continued by Bhuvan.
Hello everyone, I am Bhuvan Raj. I will continue by creating a new virtual machine. A virtual machine is a software-based computer that runs inside your actual computer and allow your install use another operating system like Kali Linux without affecting a main OS like Windows. First one, initialize virtual machine. Open Oracle VirtualBox software and click new button in toolbar to start creating a new virtual machine. Machine folder location on your computer where the virtual machine file will be stored. Version Debian 64-bit Kali Linux based on Debian. Second one, select OS image. VirtualBox will be asked for an iOS file. This is a digital copy and installation DVD. Choose an Kali Linux iOS you are downloaded from the official Kali website. Next, third one, allocated resources. You must dedicate how much your computer's power to give to virtual machine. RAM, memory, allocate. Next, fourth one, set storage limit. The virtual machine needs a virtual hard drive, file stored on your real hard disk. Next slide. Okay. Virtual installation. Open VirtualBox, select the newly created virtual machine. Example, Kali Linux. Click Start. VirtualBox will be now boot the or using iOS file you attached early. Next, second one, boot sequence. You see Kali Linux boot menu. Select a graphical install and option. Kali Linux step begins. It checks everything RAM storage iOS file in working currently. Next, isolated installation. All installation files, settings, and go to configuration remain inside the virtual environment. Your main OS is Windows 11 is not affected. You can safely run testing tools, learn networking or performance experiments without any security risks. Thank you.
Now I will be explaining the launching the guest OS, the boot process. Here the VM initialization. The VM is started directly from the virtual box GM interface. The boot sequence. The Kali Linux boot screen appears confirming that the VM is functioning correctly and accessing the installation media. And the isolated installation. The entire OS installation and setup occurs safely with the virtual environment isolated from the Windows 11 host system. So the next process is observing core OS concepts in the Kali Linux. Here we use the terminal commands to see how the OS works internally. Uh, Top command shows the live CPU and memory usage, shows CPU scheduling. PS command lists running processes, shows the process management, and helps us understand how the guest OS manages resources like a real system. So in the next slide, host OS guest OS a comparative view. host OS is Windows 11. Here the real system, this is the real system that controls hardware. Guest OS is Kali Linux, runs inside the host using VirtualBox. RAM gets a fixed share, example 4 GB and an 8 GB storage. CPU is when guest uses assigned cores, like example 2 cores, 8 cores, and multiple cores. Usages of host for daily work and guest for testing and security practices. So the next slide will be continued by Pawan.
This topic is key operating system concepts in a virtualization context. Process management. Each virtual machine or container appears to have its own isolated set of process and threads, even though they share the same physical CPU and memory. Hypervisors and container runtimes that must manage scheduling across guest OS processes while coordinating with the host of OS scheduler. Next, memory management. Visualization adds an extra layer of memory abstractions, guest virtualization memory to guest physical memory, next host physical memory. Its techniques are that shadow page tables or extend page tables or nested page tables. Memory ballooning, dynamically reclaim unsent memory from a virtual machines. Next, CPU scheduling. Fairly allocated CPU time among virtual machines or containers. Hypervisor level scheduling. The hypervisor scheduling virtual CPUs onto physical CPUs. Nested schedulings are each guest OS schedules its internal processor on vCPUs. Next, conclusion part. Conclusion and key takeaways. Virtualization and operating system concept. Virtualization fundamentally builds on core operating system principles such as process management, memory allocation, scheduling, and IO handling, but extends them to manage multiple isolated OS instances on the same physical hardware. The hypervisor means or container runtime act as an extra control layer, ensuring fairness, efficiency, and isolated among virtual machines or containers. The key takeaways are virtualization like OS concept at scale. Everything on OS does for processes and resources. Next, resource abstraction. CPU memory, storage, and network resources are virtualization and share among multiple virtual machines or containers. Thank you.